Swayam Prabha. Digital India. Educated India.
So this is what I would do. If you can settle down and let me speak, that'll be wonderful. Thank you. So this is what I would do. I would briefly explain the cutting plane method. And there was a little bit of confusion. In fact, there was quite a bit of confusion with regard to how to determine the visibility using the cutting plane method. I would actually tell you not to worry about that. So find the intersection between the two planes using the cutting plane method, and then use the projection method to figure out the visibility. So I'll talk about that. Okay, so let me get started. Cutting plane method. So stay with me. All right. So given two planes ABC and DEF, we figure the line of intersection between these two planes using the cutting plane method. So the trick is very straightforward, pretty much along the lines of what we had discussed when we studied the interaction between a line and a plane. You just imagine that you have to treat one of the planes as planes and the other plane as a set of three lines. Okay, for example, you can treat plane ABC as plane ABC and DEF as a set of three different lines. Okay. Now, for example, if I treat DEF as a set of three different lines, let me pass an imaginary cutting plane through the edge DV and let me call it CP1. Okay. Now this edge DV is going to be intersecting with ABC at this point and this point. Okay, so between an imaginary cutting plane and the plane ABC, what do you expect? Do you expect a line of intersection or a point of intersection? Line, right? Project this point up, so this point will be lying on AB. Project this point up, it lies on AB. This point, it lies on BC. Project that point up. This would be the line of intersection between the imaginary plane that passes through DE and the plane ABC. And that would be the projection of that line. Okay. Now this line is going to be intersecting the edge DE at this point. Okay. So this point would represent the point of intersection between the line DE and the plane ABC. Fine? With me so far? No? Yes? Good. Take another plane. That plane passes through DF. Let me call this CP2. This plane is going to be intersecting ABC at this point and this point. So this point lies on AB, this point lies on BC. Project this point up on AB, lies over here. Project the other point from here, lies on BC. This would be the line of intersection between the plane ABC and the imaginary plane CP2. Now the corresponding point of intersection will have to lie on DF. Okay, so to get that point of intersection, you have to extend DF, okay, and get this point of intersection. So it's okay for that point of intersection to not lie on a plane and a line as of now. So this is your first point of intersection, this is your second point of intersection. Join these two guys, and the line segment that would be the line of intersection between the two planes has to be common between both planes. So this would be the line of intersection. drop that down and you would get the corresponding projection in the front view. Straightforward with regard to computing the line of intersection between the two planes. Now, to get the visibility, go for projection. Now, I chose this view for absolutely no reason. I could have chosen the top view, I could have performed the same thing, and I could have expected the same result. Okay? I could as well, I could have treated ABC as a set of 3 lines instead of DEF. I could have still expected the same result. I could have as well chosen this as my cutting plane. Okay? The result would have been the same. So keep that in mind. Are you with me now? Yes? Now, to figure out the visibility using projection method. So a few lectures ago I said that I did not get any logic behind the projection method, but it looks like there is some logic, and the logic is as follows. First things first, you realize that all these edges, they are going to be visible. All these edges, they will be visible. Okay? Even the line of intersection will be visible. So keep that in mind. So we need to figure out the visibility of this segment, this segment, this segment, this segment, this one here, and this one, this one, this one, this one, this one, and this one here. Okay? Now, look at this point, for example. Drop a vertical. What would this point represent? What would this point represent? Is it a common point between 2 edges? Is it a common point between 2 edges? No. The edges may be intersecting at that point, may not be intersecting at that point. Okay? So the edges are DE and BC. So DE is like so, for example, and BC is like so, for example. Okay? Now what you see is the top view, and what you see is this point here. Look at my finger and the thumb of the right hand and finger and the thumb of the left hand. So these 2 points, they are at the same position in both edges in the top view. Okay? Now which of the sticks is visible to you, or is it closer to you? The one on my right hand, the one in my right hand, or the one in my left hand? Right hand. It's visible, right? You could see that. Okay? But there it's not clear. Now what I would do is I would just flip this over so that you could see the front view of this. Once again, I would just flip it up so that you could see the front view containing the projections of these 2 lines. Which of the points is up? This guy here, right? So that's up. Okay? Here it's visible, here it's up. Once again, it's visible here in the top view. In the front view, it's above this point. The logic is precisely the same. If you drop a vertical from here, okay, whichever edge is up in height in the front view will be visible in the top view. Logic is precisely the same. So if you drop a vertical from here, okay, DE seems to be getting hit before BC, nah? Right? So it is this portion of DE that would be visible and therefore solid. Agreed? Okay. How about this one? If I drop a vertical from this intersection point, so now that's intersection between EF and BC, which of the edges will be encountered first by this vertical? BC. So that means that BC is going to be visible here. So this portion is going to be visible here, and therefore it's going to be solid. With me? Okay. Now, if you look at this one back again, so it is DE which is visible. When this portion is visible, this portion of ABC should be hidden. Yeah? One thing more that you would want to notice, what has this intersection, line of intersection done to this edge? It has changed the status of that edge. So this edge was visible from B up till the point of intersection, and from here it is hidden. Okay. Likewise also, you can expect something very similar over here. So this is visible here, and from this point onwards, edge DE should be hidden. Yeah? You can verify that. For this vertical, what do you expect? What do you expect for this vertical? Point of intersection between DE and AB. AB gets hit first, so it's AB which is visible, right? And of course this will be hidden, and likewise you can figure out visibility. Same thing from this view also. So extend a vertical upwards from any of these points of intersections, see which of the corresponding edge is hit before, and that edge is going to be visible in this. Same logic. With me? Everybody? Absolutely confident? All right, so this is what I would do. This is what I would do. I would distribute the question papers. I have them. Question 1, question 2. 2 questions. Relax. I'll give you enough time to solve these questions. Okay, so I will give you a single paper, and these 2 questions are on the 2 sides of that paper. Okay. While you are solving that, for reference, I'll keep this slide in front of you so that if you are stuck, you can refer to this and solve. So this is the front view of the object. This is the auxiliary plane 1, auxiliary plane 2, and looks like I will be able to show the 2 shapes only using auxiliary planes, not otherwise. Now the question is this: given the partial auxiliary views of this object containing true shapes of the planes or faces, if we have to draw the orthographic projections, like the full top view and the side view of this object, is it possible for us to do that? That's what the question is. Okay, so this is the object, and we would like to draw the full top view of this and full side view of this. Now this part is straightforward. I can always take vertical projections. Okay, draw the square or rectangle or whatever. So this part is going to be visible. This edge will be hidden. Okay, and likewise I can take the vertical projections from these edges. So likewise this edge is going to be hidden over there. Okay, I can take the vertical projection from there. This edge is going to be visible. Likewise this edge. Okay, and over here vertical projection up, horizontal, horizontal, the center line. Okay, and now the question is, how do we transfer the features over here onto this part of the drawing in top view. How do we do that? Step 1, break this arc into a number of segments, right? And then look at these projections, transfer these projections over here, and from here up to the top view. Okay? So these 2 points, they get transferred over here. Let's first look at the bottom face. From here, transfer them up, right there. Second thing, transfer these 2 points over there. Likewise, the center line up there. Okay? And here comes the critical part. Now, of course, these 2 views, they are going to be separated by a hinge line. How do you find the position of this hinge line? Okay? Now, to do that, look at this feature and compute the distance or take the distance of this point from the hinge line over here. Okay? This feature is going to be lying where? Where? Over there? Yeah? Take it up. This feature is going to be lying over there. Measure that distance. Okay, and then look at the hinge line. So once you have the hinge line, now it becomes a lot easier for you to transfer whatever distances you're going to be measuring over here up to here. Same thing, the concept of auxiliary planes. Now, so this view happens to be the common view. Okay, get the distances from the auxiliary plane and then transfer all of them onto the top view. Straightforward. Clear? Clear? So I don't have to speak much. Get this distance. Now this point lies on this vertical projection, this one. Measure that. Get that distance. This one lies over here. Measure that. Get this distance from here to here. This guy lies over here. Measure that. Straightforward. Okay? Now take this distance and place it over there. Likewise, take this distance, place it over there. Okay? So it looks like you have gotten these points to lie on some sort of arc. Okay? This is how the arc is going to look like. And so this is the bottom arc, remember that. So this is the arc corresponding to this part of the object. You could do the same thing for the top part of the object. Okay? Real quick. Same thing for the top part of the object. So the top arc is going to be visible, so it's going to be solid. The bottom arc apparently is also going to be visible. Look at this. So this part is going to be visible, therefore solid. This part is also going to be visible, therefore solid. Okay? And then this edge is going to be visible. Right? How about the circle? So there is a void over here at the bottom surface, there is a void over here at the top surface. Okay? Treat them one by one. Same thing, same distances concept. So divide the circle also into equal parts and take distances of the points lying on the circle from the hinge line and transfer them. So once you understand the basics, it's all straightforward procedure. Transfer the distances and this corresponds to the circle on the top face or the bottom face? Top face. Likewise, do the same for the bottom face. I'm just transferring distances. There are going to be many lines. I'm just transferring distances. Okay, so this is possibly this part of the circle, okay, and a part of which is going to be visible in the top view. So this would be solid. The other part, the same thing, transfer distances. Okay, a part of this circle is going to be visible, so this would be solid. The rest will be hidden. Okay. Do precisely the same thing on the other side. Okay, now for that you're going to be using this auxiliary view. Precisely the same thing. Measure distances and transfer distances. Okay, when you do that, you would get that part of the arc. Now this part of the arc is going to be visible. This arc on the top face is going to be visible. How about the bottom face? The arc corresponding to the arc lying on this face, not visible, that will be hidden. Okay, how about the circles or circular voids? Same thing. So the void on this face is going to be visible. The void on this face, a part of it is going to be visible, a part of it is going to be hidden. So this part is visible, this part is hidden. Okay. Now you can do a smart thing. Observe the following: the shape of this arc and the shape of this arc. What do you observe? Are they the same or different? They are the same. So if you get one arc, all you need to do is transfer the corresponding points over here, okay, by equal distances, and then get the other arc. Likewise from the other side. So once you get this arc, okay, just shift this arc by some amount. What is that amount going to be? What is that amount going to be? That amount is going to be this, is it? Is it? Yes or no? It gets, so this arc gets shifted inward by about this amount, no? Yeah, likewise from there. So this arc gets shifted by about this much amount, right? Side view again, the same thing. Yeah, of course, finish the top view by adding center lines. So side view again, very similar concept. So I'll not say much, just that I'll show you the animation. Okay, so if you had asked what we had been doing in the last 5 or 10 lectures, we actually had been preparing a primer for such problems. What if the planes are not parallel to the conventional orthographic planes, x, y, y, z and x, z? What happens then? So we have to take the help of auxiliary views, and that's the reason why we call them auxiliary planes, helping planes. So unless and until you get the true features in the auxiliary views, you will not be able to capture them in conventional orthographic projections. Any questions? Any questions? Are you with me on this? Everybody? Everybody? So I've made the speed of this animation quite slow so that you can follow what's going on. The lab next time that you're going to be doing, I think that's going to be after the mid-sem break, is it? Or after the mid-sem break? So that's when you're going to be solving these problems. Jan 25th with me. So while you're watching this, I have the benefit of having not many of you. So we can talk about the exam. Okay? It's going to be a 4-hour exam, the NCERT, 7 questions, 4-hour exam. The first batch is going to be writing the exam between 9 and 1, 4 hours. The second batch is going to be writing the exam between 2 and 6. We'll do something very similar to what we did last time. We'll have to quarantine batch 1, okay, for half an hour, and then we'll have to let batch 2 in, and only then batch 1 gets released. Now this time what I've done is I've just reversed the batches. So batch 1 in the mid-sem is now batch 2, and batch 2 is batch 1. Okay? The questions are going to be tough. The questions are going to be tough. It might happen that 4 hours may not be adequate for you to solve these questions. Okay? I'll think about whether I should be providing you some sample questions or sample paper or not. I'll think about that. Okay, but I would request you guys to practice and practice hard, because these concepts are difficult to follow. So unless you practice, you'll not be able to get these concepts. And if you don't get these concepts, you'll not be able to solve the questions. No. So the questions will be from perspective till development. Perspective, 1 question on perspective, 3 questions on lines and planes, 1 question on this, 1 question on intersection, and 1 question on development. 7 questions. Huh? Oh, you have to wait for 5 more lectures. So we haven't yet discussed interpenetration of solids and development. So 5 more lectures. Yeah? None. This was the bonus quiz. 10 marks straight out. 10 marks getting added to your score straight out. What? 200. 200 marks. 7 questions. 40, 35, 35, 20, 20. I can give you the paper if you want. Huh? None. What? What is the meaning of a bonus question? To me, it means you get extra credit for extra work. Added. It is more. So if you have, let's say, 8 questions, for example, okay, essentially you can get 120 out of 100 as in the mid-sem exam. Okay. So I must warn you, if you are not careful in the labs that you're going to be working now, or if you're not careful in the lectures to come, if you're not attentive, it might be a little difficult for you. In your position, I would probably try to understand everything that I learn from now on. Okay? I'm here, I'm committed, so I can give you n number of extra classes. I'm committed. The question is, are you? I just want to make sure that you understand. Okay. What, you guys are already tired of Tier 101, is it? This is something interesting. A few days ago, myself and two colleagues of mine, Professor Sudhir Mishra and Professor Joydeep Datta, mathematics and civil engineering. So we were having dinner and we were having conversation. So Tier 101 sprung up and we started discussing Tier 101, and I'm on camera, but I'll be honest. Okay, so you know, I kind of confessed that I was having a hard time teaching Tier 101. Looks like I am not able to deliver the concepts properly, and my students are having a hard time. I mean, I look at their faces, I look at their eyes, and they're like, and I really wonder if I'm doing a good job in teaching Tier 101. And they said, well, I mean, things become a little difficult, starting from space geometry, a lot of imagination, a lot of visualization. And Professor Joydeep Datta, he's a mathematician, right? So he's like, yeah, what's the use of Tier 101? I mean, why are you teaching Tier 101? And Professor Sudhir Mishra is like, you know, you have to teach the language of drawing. I mean, you have to teach the language of drawing. I mean, you have to be able to convey without using words what you mean, okay, when you have conceived a design, for example. What you want to convey when you have conceived a design. You should not be able to use a single word. Like, for example, if a designer from there comes to a manufacturer from here, he or she would come with a drawing, and he or she would be able to interpret without an exchange of a single verbal word. That's what he meant. Seemed okay. But then I began thinking, and I was like, you know, the first thing that you conceive, the first idea that you conceive, if you want to convey it to yourself, and if you want to develop it further, what do? You take a paper, you take a pen, and you draw a line, you draw a curve, you draw a sketch. That's the first thing you would do when you want to conceive an idea and develop it further. Okay? This helps you with that. This helps you with that. No numbers involved, no words involved, only drawing. It helps you imagine things a lot better if you're doing it right. So it is important. Take Kriti, for example, or, you know, Galaxy. You know, this is art. Production in Galaxy, you build structures. I've seen that. You build huge structures. Many of them are new ones. Many of them are new constructs. What do you do in there? You imagine things. You try to convey new ideas. Okay, but this is where, this is your foundation. This is where you develop. This is your factory. This is where you develop the ideas. Build it. Convince yourself that your idea is going to work. And then implement your idea. So this is how important Tier 101 is. 101 is basic course to thinking and analyzing. Think and analyze, only to geometry. But I still convey, I still have this feeling that I'm having a hard time conveying what I know or what I don't know to you. So hopefully things will get better from here, with only 5 lectures to spare. All right, so I won't I would release you because you have a quiz at 6 o'clock. So